The ME229 group design challenge this year was to create a wind-powered car. We needed to design a car that was simultaneously fast and could carry a lot of weight, as the goal of the car was to transport cargo to a specific target zone in as small amount of time as possible. The car also had to fit in a 1 cubic meter starting zone, and we decided to go with designs exclusively powered by wind without the use of potential energy systems such as springs or ramps, giving the wording of the design challenge and the limited starting zone area. Each group member was in charge of coming up with a unique design to bring to the table, prioritizing different objectives.
Alright, so this is our first design. It has a spinnaker sail and a very aerodynamic shape, but it has no brakes, so it doesn't stop.
Second design is this cup-powered vehicle. It uses the wind with the cups and some sort of braking mechanism.
So my design is a Darius wind rotor, direct drive connected to the rear axle using a string brake system.
And my design is also direct drive using a wind turbine with a belt connecting to the rear axle, and then it's got a lever braking system, a wind lever braking system.
We then assessed each design using a weighted decision matrix, prioritizing different objectives across the board.
Comparing four main things here: braking accuracy, propulsion, cargo carrying, and embodied emissions. And out of all the designs, the Darius wind rotor ended up scoring the highest with 3.9.
We then began iterating the Darius wind rotor design to better fit the competition conditions.
So we began with the Darius wind rotor, which requires a block of wind to come in, but we're working with just a single leaf blower, so it's not very effective with this design. So we changed it to work with cups, so it's a streamlined line of air coming into the cups and can blow it more efficiently. And then we got rid of the bars, so it's more easy to manufacture.
The next step in the design was making working drawings as well as accurate computer models of our final design using Inventor, so that it would be easy to manufacture with consistent measurements once we were in the Fab Lab. Once in the Fab Lab, we realized we were limited in our manufacturing materials and processes, so we decided to laser cut the rotors, wheels, and gears. We made the frame out of plywood, and we 3D printed the drive chain, and it all came out very well. The rotor and wheels ran very smoothly, and in initial unloaded testing, it worked great. The brakes put us right in the target zone, but problems arose with the braking system when we fully loaded the weight. That sound was the front axle snapping from the fishing line brakes. So we iterated again using double string braking near the edges of the frame. Trying different solutions took the rest of our fabrication time, and on competition day, we could only hope for the best. The brakes worked, but the elasticity of the string and the lack of bearing friction let the car roll too far the other way and out of the target zone. In the end, even with this setback, we succeeded in what we set out to do. We designed a wind-powered car from start to finish that was able to carry the full cargo to the end zone quickly, and that's what matters most.